Welcome back. These are questions 7 through 13, I believe is what I'll stop at. Uh, Probably stop at question 12, excuse me. So this will be question 7 through 12, and we're going to dive right in. It says, which expression is equivalent to this? Okay? And what's the one thing that stands out here that we don't like? It's negative exponent. We can't have negative exponents when we're writing an answer. So how do we get that? Well, it's a simple thing. Whenever you have a negative exponent, no matter where it's located, you're going to move it to the opposite side of the fraction bar. Now, do you see a fraction bar here? Me neither. There is an understood fraction over 1. Just like if I said, what is the fraction with just the whole number 6? Everybody should know that's 6 over 1. But it works even if you have letters. If you look at A, what's A as a fraction? A over 1. Okay? Because A divided by 1 doesn't change the fact that it's still A. So, we have our fraction bar now, and this means that we need to move this whole B base here, okay, or power, to the bottom. And when you move it to the bottom, the whole reason we're moving it to the bottom is to have a positive exponent. So you're going to leave the 3a squared alone because none of those have a negative exponent. You want it to be the negative exponent that moves. And then b to the third will be on the bottom, and that'll be your final answer. Looking to question 8. Okay? We have one of these things. Notice how it does not have an addition or subtraction sign in there, but it has an exponent on the outside. When it has this exponent on the outside, it's really exponent division. So you got to look for that addition or subtraction in between the variables, okay? Or in between the letter and the number, okay? This is a negative 4, so don't let that be like, oh, it's a subtraction. No, that's negative 4. So the other thing I told you to watch out for in the previous question is that understood 1 that's in there. So B has his exponent. A has her exponent. What about 16? His exponent is 1. Okay? So we need to make sure that we put that 1 there and that they get the 3/4 as well. Okay? So we're going to take this and we're going to distribute it, and you get 16 to the 3/4 power. You get a to the negative 4 times 3 over 4. And you get b to the 12 times 3 over 4. Okay? Now, 16 to the 3/4, you can use your calculator. Um, we learned in the previous question, question 6, that you can turn a radical into fractions. Well, this would be the same thing as saying the fourth root of 16 to the third power, or 16 to the third, like that. It doesn't matter how you write it, but the fourth root of 16 is 2, and then 2 to the third is 8. Or you just type that in your calculator and get 8. Okay? I'm not going to stress out about this because you'll have your calculator and you can do 16 to the 3/4 power in that. Okay? When you're multiplying a whole number and a fraction, remember to multiply the whole number to the numerator and then divide by the denominator. 4 times 3 is 12. 12 divided by 4 is 3. And then that's a negative. So you get a to the negative 3. Then you do 12 times 3, which is 36. 36 divided by 4 is 9. So you get b to the 9th. Can we leave it like this? Absolutely not, because we have that negative exponent. Okay? So when you have a negative exponent, remember there's an understood fraction bar there, and whatever term or part of the term is negative with the exponent, it goes to the bottom. So we'll leave the 8 alone because it doesn't have a negative. We'll leave the b to the 9th alone because it doesn't have a negative. Okay? But then that a is going to come down to the bottom, and instead of having a negative 3, it's going to have a positive 3. Okay? And that is your final answer for that. On to question 9. Alright. So it says, given this formula, solve for f. So this is one of our literal equations. Okay, it doesn't want us to figure out what the actual answer is because we have two variables and only one equation. You have to have two equations to solve for two variables. Okay, so you're going to want to rearrange this. So I'm going to write it down here. C equals 5 over 9 f minus 32. Okay, so now in order to solve this, you locate your target variable and then you say, well, what is actually happening to it? Well, first they're subtracting 32, and then after they subtracted 32, they multiplied it by 5 divided by 9, or 5 over 9, or 5/9, however you want to read this. Okay, so you're going to have to come up with a system of how you want to get rid of this. Okay, well, since I know y'all are going to struggle with fractions, let's go ahead and get rid of this 9. Okay, notice how this is multiplying to everything, so we can get rid of it first. Okay, we can't get rid of this minus 32 because it's stuck inside this parentheses. And I know you're going to be tempted to multiply or distribute. Please don't. You're hurting yourself in the long run. It's going to take way longer when it's easier just to go ahead and get rid of it right out the gate. Okay, so how do you get rid of a divide by 9? You multiply by 9. So you're going to times by 9 and times by 9. Whatever you do to one side of the equal sign, you do to the other side of the equal sign. 9 divided by 9 cancels out. 9 times c is 9c equals, what comes down here? The 5, okay? And then you still have f minus 32, okay? And now you're like, oh, yes, now I don't have a fraction, I can distribute. No, don't distribute, because this says 5 times all that. How do you get rid of multiplying by 5? You divide by 5. So we're going to divide by 5. Technically, you divide the whole thing, okay? Divide by 5 here. And so you end up with 9c over 5 equals, and then 5 divided by 5 is 1, and then you're left with just f minus 32. Okay? Now, what's happening to f? It's being subtracted by 32. How do you get rid of that? You add 32 to both sides. And then I say, well, what is 9c over 5 plus 32? And you say, 9c plus over 5 plus 32. I was like, yeah, that's right. It's 9c over 5 plus 32 equals, and then that cancels out, so all that's left is f. Okay? And that could say 9/5 c. It's very similar. But that's how you can write it, and it means the same thing. Okay, question 10. Look at question 10. It says, sides of the quadrilateral are shown. Express the perimeter. Okay, perimeter. That's the outside. We're going to figure out how far around the outside of this shape, this trapezoid, do we have to go. Well, to find that, you just add everything up. Okay, and so you've got x plus x, which is 2x. 2x plus 2x is 4x, and 4x plus 2x is 6x's. Okay, and I'm combining the x's because they are like terms. They all are x's to the first power. Okay, two, and you can do it any order. 2 plus 2 is 4. 4 plus 1 is 5. 5 plus 1 is 6. So you have 6 x's. Notice how I didn't try to square the exponent or anything like that, because we're adding, and when you add, you don't do anything to exponents. Okay? So then we look at the numbers. You have 2 plus 4 is 6. 7. It's 7 plus 5 is 12. And then you can clearly see that that's the answer. Okay? Question 11. Got quite a few of these. We felt like you guys could really use some help with these exponent properties. Okay? Spent a lot of time with these. So now you look, notice how there's no addition or subtraction in here. Okay? So that means it's exponent distribution. There's a number and a letter, so each of these get it. Don't forget about your understood 1 there. So you get 3 to the 4th, and then you get r squared times 4. Okay? Or the 4 is times the 2, excuse me. Okay? And then 3 to the 4th is 81. Okay? And r to the 4 times 2, or 2 times 4, is 8. So you get 81 to the 8th. Say, Miss Polk, how'd you get 3 to the 4th power is 81? That's 12, right? No, this means 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9, 81. Got it? That's how it's 81. Okay, looking at number 12. It says, Carol has 3 times as many $10 bills as $5 bills. She has a total of $350. How many $5 bills does Carol have? Okay, this one's a tricky one. People always like to get this wrong because they want to read it and just go, oh, 3 times 10. Got it. That's not actually how it works. You got to read it and pay attention to which thing's going to be bigger. So we know we have $10 bills and we have $5 bills. Tens and fives. Okay? She has 3 times as many $10 bills as $5 bills. Which one has more $5, or which one has more to it? Is there more tens or is there more fives? And you should say there are more $10 bills because there's 3 times as many tens as there are fives. Okay? So you could do 3 times T equals F, or the other way to do it is T equals 3F. 3 times the tens equals the fives, or the tens equal 3 times the fives. It just depends on how you want to look at it. So we know that there should be more tens than there are fives, right? 3 times as many, right? So just pick something that you know that's easy to get 3 times. What if we had 2 fives? How many tens would there be? Well, there's 3 times as many, so there should be 6, right? So let's see which one, if you plug 2 in for F, will give you 6. Okay? So if I plug 2 in here, you have 3 times T equals 2. So then, to solve for this, here, let me erase it over here. So you got 2 equals, and then 3T. So I just plug the 2 in for F. Okay? And then you divide by 3, T equals 2/3. So did that give us what we wanted? No. So then it must be the other equation. So let's see. You had T equals 3F. Well, F was 2, remember? We made that number up. It wasn't in the question. I just wanted to see which equation was going to work. And then 3 times 2 is 6. And so that means we had 6 $10 bills. Absolutely. That gave us what we wanted. So this must be the equation that represents. Okay? Then it says she has a total of $350. Okay? So she has a total. That means when you add up your fives and you add up your tens, you get $350. Well, you have your tens plus your fives, and that equals $350. But this is the amount of bills. If you have 2 tens and 3 fives, that would equal 5 bills, right? But that's not how much it's worth. So you have to include how much each bill is worth. So how much is a 10 worth? It's worth $10. How much is a 5 worth? It's worth $5. Okay? So keep in mind that's what you're working with. Okay? So now we have 2 equations. We haven't even solved anything with 2 equations. However, this is very similar to an age question where it tells us that the tens are 3 F's. So we can take these 3 F's and plug it in for this equation. So you have 10, and then that becomes 3 F's plus 5 F's equals $350. Well, what's 10 times 3? You get 30 F's plus 5 F's equals 350. And then 30 plus 5 is 35 F's equal 350. Divide by 35. Okay? And then you'll get F equals 10. And what did F stand for? That was our number of fives. What did it ask for? How many fives does she have? She has 10 $5 bills. Okay? That concludes questions 7 through 12. If you were confused by question 12, don't worry about it. That was just a word problem, getting you used to using your vocabulary and trying to put something down on a paper. There's not one exactly like that one on the midterm, but there's some that have similar concepts, such as substituting in the t for the other t. Okay? Please continue on for questions 13 to 20.